All right. Well, good afternoon, everyone. Thanks for joining the last session of our brown bag series on using R for analyzing agricultural data. We've had quite an adventure of it over the last few weeks, and hopefully you've gotten a chance to see how R can be used for a wide range of different things. The first session we talked about tidy data and how R can be used to prepare data for analysis. We talked about in the second session, Clark introduced us to some of the tools within R to be able to do data cleaning and some of the quality checking and things like that. Last week, I guess I should introduce myself, Phil Alderman, in case you forgot. So I last week talked us through how to do some basic data analysis from summary statistics through to analyzing data from designed experiments, and then even using R for analysis of sort of exploratory analysis with larger data sets. And so today our topic is looking at data visualization. How can we use R to visualize different data sets, to be able to understand them, to be able to communicate the results of our studies. And so Kay Bjornen is going to pick up with the lesson for today and demonstration for today, talking about that data visualization. Before I hand it off to her, though, I want to mention to all of you that are here that if what we've talked about through this series is something that has sparked an interest for you, and that you want to learn more, we will have, we on a periodic basis, the library offers different data carpentry workshops specifically geared toward getting people up and running in R. And those workshops are a different format than what we've done here. Here we focused on demonstration only. Those workshops are very hands-on and helping you do your analysis or do your steps through learning those skills. Basically it's very interactive, and you go step by step. This is how you do it, and then they give you a chance to do it. And if you're having trouble, then people are available to help you through that. So please sort of keep your eye out. I think we have one more workshop that's planned for the fall semester, which is focused on genomics. So if you are interested or want to learn more about that, you can look into that one. And then additionally in the spring, be looking for announcements about our workshops in the spring. There should be at least one or two also that'll be offered at that point in time. And so I think did I forget to mention anything, Kay? I think those were all the announcements we wanted to make. One other thing, we will be sending out a little survey to you guys that have participated through in a couple weeks, and so keep an eye out for that as well. Anyhow, with that, Kay is going to introduce us to some of the wonderful tools that we have within R for doing data visualization, and so take it away, Kay.
Okay, thank you, Phil.
I have started with the libraries all read in. They following Phil's excellent best practice of adding all the libraries at the top so that you can tell what you've loaded easily. And I've got our weather data read in. And now let's just talk a little bit about what I hope we will get covered today. The plan is to start out with the basics and just build up to some pretty cool and sophisticated stuff at the end. And the intention is to help show everybody what you can do with ggplot for both data inspection and for decision making. And then I don't think I'm going to have much time to do much in depth, but I'm going to do a quick show of a couple of important things for purposes of communications. Because usually when you're doing data visualizations, at some point, those will be used for either publications or presentations, and that's all about effective communications. So Okay, we're going to start with some of the data that Phil used last week for modeling. And if you recall correctly, he used the Yates Oates data. And that is a data set that is already in the Agridet package. And so it shows up in our console over here. And that contains the results of a designed experiment where it's got some columns that are actually part of the experimental design, like the block and so on. But it also has the yield, it's got the nitrogen levels, and it gives us grain and straw as outputs. And so let's look at that real quickly, because there's a couple of things that are not useful in this data set with regard to the data types. So for instance, our nitrogen, even though we only have 4 values, it shows up as a numerical, and it's going to be a lot more useful if we create turn that into a factor. And so we're going to make another object where we are going to mutate our nitrogen into another column called NFAC for the nitrogen as factor. And with that, what we're going to do now is we're going to create an object, and that object is going to be the start of our plot. And so this is a good place to explain a little bit about how ggplot works. So ggplot is a package that is rolled up in the mega or meta package of tidyverse, and it contains so tidyverse contains a lot of sub packages, and ggplot is one of them. And the way that ggplot works is it creates layers. So the very first layer we are going to create here is where we tell it what our data is. And so our data, in this case, that we're going to plot from is Oates data. Okay, and it helpfully supplies that, so I don't have to get it typed right. And then the next thing we have to do is create what is called aesthetics. And this is a process that is called mapping. And by mapping, what we mean is that we are going to tell ggplot what variables we want to actually create on our plot. So we're going to use NFAC for X, that's our X variable, and then we want yield for our Y variable, and then we're also going to tell it that we want it to group according to the NFAC column, because that's going to make our plot a little tidier. Okay, and so this should create the first of our objects. Apparently I, again, have something in, oh, no, data equals Oates data, have an unexpected comma. Yes, okay, yes I am, okay. I added in mapping and forgot to tell it it's an aesthetic, so. Okay, that works better. Okay, so now we have the B showing up in our environment. And so now what we're going to do next is we're going to take that object and we're going to add the next layer, which is called a geome. And for our data here, what we're going to do is we are going to create a box plot. So the geome box plot shown here is a subroutine, if you want to call it that. And you can see that it very quickly takes those factors. It shows the NFAC the nitrogen level as a factor down below, and it plots the yield for those data points in those box plots. And if you were doing a quick scan, that might be enough to tell you, there's not a lot of difference between those, especially the higher nitrogen yields. But you might want to add to that. And so we are going to say, let's take our B object and let's add a geom, let's add a scatter plot or points rather on top. And let's give it some color. So you'll notice that the fields, the arguments are empty when I did the first plot. And that's because we allowed ggplot just to use the default arguments and didn't supply any that were not defaults. But this time we're going to tell it we want it to use some color, and that's for making our points easier to see. And so we'll use a red color. And then the next thing we're going to do is we are going to add some labels. And these are labels that were taken from the information provided about the data set, which I found by looking at the help menu. And so it just is, we're going to give it a title of Yates-Oates experimental data, and then we're going to tell it we want labels for our x-axis. And again, this is taken directly from the information about the data set because I've never heard the term manurial before. But that's what it says it is. So, and I think it's especially helpful that we know that the units for this are in hundredweight per acre. And then we also need a Y label. So that will be equal to the yield in 1/4 pound per 1/80th acre. And if we did that right, except we left off the box plot. So, okay, so there's our data points, and we're just going to go back and add geom box plot and look at how it looks with both plot types together. Okay, because I added the box plot after the points, it put the points behind it. Let's change that, get rid of that, and we'll add the box plot. And because what I wanted to do is show one more thing, which is that another function that we can use with the box plot is a notch. Okay, and we still have to. Let's see if I got that straightened out. Okay. Can't add B to a ggplot. B geom box plot plus, oh, all right, there's our problem. Okay, this time it worked. All right, so you see that the notch shows you, it emphasizes where the median is for the data, and by plotting the points over the top, it gives you additional visual information. There's one little glitch here, and it shows up in the console as kind of a notice. And that is that for the 0 nitrogen, it says that the notch went outside the hinges, which just means it flips up here a little bit. That doesn't detract from the fact that it's still a useful plot. So we will leave it alone. All right, so the next thing we're going to do is we are going to go back to another AgriDat data set that Phil used last week, and that is we're going to look at the Diggle cow data. And so to refresh your memory, we're going to run a summary here about that. And again, this is a data set that was the output from a designed experiment where cows, and that shows up in the animal column here by letter and number, and the were either fed extra iron in their diet or no extra iron in their diet. And some of them had a pathogen that they were exposed to, and the weight was collected at about 10-day intervals. So the weight shown here is the statistical output for that. We do have one NA that shows up, so that can mess with our data a bit. And then the day category. And so one of the things that we're going to do is we are going to first just take our Diggle cow data, and we are just going to create a very quick, simple scatter plot. And so we take our Diggle cow data and we pipe it to ggplot, and we tell it that we want to plot the day as X and the Y is weight, and we want to use genome point. And it removed one missing value for us. And you see what we get in the plot window is our data sets shown by day. And you can just, it does give some information about the distribution over time, but we can do better than that. So one of the things that we are interested in is the interactions. And so we are going to take the data for the very last day the data was collected, and we are going to look at, we're filtering out day 781. That was the last day data was collected. And then for ggplot, we're going to tell it use as X. We want the interaction between iron and infected, and Y weight, and we want to group it by that interaction and do another box plot. So let's see what happens when we do that. Okay, and there's our box plot. And you see at the bottom, it's been grouped according to those interactions, and the weight distribution is shown. We see a couple of outliers. And so that's, again, useful information. But we're going to compare that now to another plot where we're going to look at that same information, but we're going to look at it in what's called facets. And so again, we're taking Diggle cow and we're piping that to ggplot. We're grouping it by animal this time. We're going to use a line, and we're going to use facets where we relate iron and infect. And so this time we get our facets are basically a grid or panes where we compare, again, we've got the days as our x-axis, weight as our y-axis, but we separate out, the iron is shown on the second y-axis, so uninfected with iron is here, infected with iron, and then down below we have no iron and uninfected. So basically this is your control group, and then infected and no iron. And so this, gives us rather a bit more information, but we're going to take it up to another notch, and we are going to create what's called a ribbon graph. So a ribbon plot, rather. And a ribbon plot is one that is going to show us statistical values such as the mean and max and mins for the weight. And again, we're going to look at it, including interactions. And one thing that I didn't explain is that the geomes are, they contain the calculations to create these, and some of them are quite simple, like the geome point, but some of them are more complex. So what we're going to do here with the ribbon plot, whoops, wrong one, is it has to calculate, or we have to provide it with the information about the statistical, the means, the mins and maxes and so on, and remove that NA. And then here is where our plot comes in. We're going to plot it by day, weight average, and use color to indicate our interactions. And we get a really, pretty spectacular looking plot with that. And your fills, you can see the fill overlaps here, but you can tell, that provides information about your variation for your measurements, as well as the lines through the middle that indicate the average of your experimental data. Okay, so we've looked at increasingly sophisticated types of plots. And so now we're going to start looking at it with some modeling. And the first thing we have to do that is we have to create a cleaned up data set. So to do that, we're going to create a data set called Clean Cow. And we're going to, again, pipe our Diggle Cow data to that. And to the filter. And we want to get rid of our, we're going to retain everything that doesn't have NA. So NA removed for the weight category. And then pipe that. To the mutate function. And we're going to create a column called time. And Phil did this last week. This is where we are going to adjust the category of day by removing 122, because that is apparently the first measurement wasn't taken until 122 days had elapsed. And then we're going to divide it by 10 to normalize it, because the measurements were taken every 10 days. And now we're going to tell it that we want to use, going to separate out our levels for our iron. And no iron. And our infect interaction, same thing. Oops, I see I have a typo there. Should be read level. Okay. And so infect and non-infected. And then hopefully that will create our clean data set. Except that invariably I have a typo, which is combined with time, why I'm going to cut and paste it. Okay. All right, got it this time. So now we have clean cow. Clean cow looks like this. And so, yes, now you see our time is in a decimal. So it's a continuous variable, and we've created the no iron, non-infected, and so on in our in those columns. So now let's do a plot with this by adding some predictions. So when we cleaned up our data set, oops. All right, so same thing, we are piping in our clean cow data set, and we're adding predictions, and we're using the cow main model. Okay, now let's see if we can make this work. All right. And you see what happened. Again, we see our data distributed by animal because we gave it, we grouped it by animal. Color shows interactions, so the interaction grouping. And then we have a line plot of the predicted values using the model. So it's a way to compare the model data with the experimental data. Okay. All right, next thing is we are going to jump ahead and look at another data set that both Phil and Clark used. And this was taken from a blog post called Train and Analyze Mini Models for Tidy Tuesday Crop Yields. And so the data is available on the internet. So we're going to go get that. Okay, so we have land use and key crop yields in there. And all of the next bit is stuff that, again, Phil did last week, where he did a bunch of, and I think Clark did as well, bunch of the mutating and rearranging data so that, did this in too fast, so that we could reorganize the data and then clean it. Oh, I left out the janitor package. Okay, and then the next one, we create tidy yields as another object, and so that we can use that. And it's there. And then we are going to use our tidy yields, and we're going to show you what that looks like with a plot. So all right. The first one I've commented out the smooth, so let's see what it looks like without that. Okay, this was our first pretty spectacular looking faceted plot of our yield data by country, and it's got the 4 crop types shown by color. So this is a plot of the data, the experimental data, and so now what we can do is we can look at this and see what does I don't think it shows up well if we use both the experimental and the modeled all in the same. So we're just going to go ahead and run it. Okay. And we told it what model, we told it we wanted to use a linear model. There's actually, the default for GeoSmooth is actually a polynomial. And so it would have looked rather different, but this gives you an idea of what you can do just by using the smooth function already contained in the Geom package. And so the next thing we're going to do is we are going to take our, let's see, did we create tidy LM yet? We have not. So the first thing we have to do is create the tidy LM object, which is using a linear model for the tidy yields. And now let's view that. And you see that the entity is the country, it's got the country code, it's got the crop, and then these fields are nested. And so in order to be able to visualize those, we have to tell we have to figure out, how to look at that. So the first step is going to be to extract slopes. All right, so we take our tidyLM object, pipe that, mutate, look at extract coefficients from the model and for tidy, and then unnest them, filter it for year, and then this is, okay, let's see. I'm not sure this is gonna be all right, creates slopes for the p-values. But I think what we wanted was not p-values. Yeah, it's not. So no, that's still the wrong one. No, it did look right. Okay. It looks okay. But this is a plot of p-values, and that was different from what Phil had pointed me to, and we were trying to. So let's see if I can do it with the intercepts. Okay, we got it. It's all right. So instead of using p-values, this creates a similar plot, but it looks at the slopes. And so this is, compares and this actually has that adjustment I was telling you about, Phil. So you can see the extreme ends for these. It's just an example of, the fairly sophisticated types of graphs that you're able to create in ggplot. Let's go ahead and zoom this one. So I think what I found out yesterday is it takes a long time. And so when I try and hit zoom with these big plots, it doesn't respond very well. So hopefully you all can see the outputs there pretty well, just by looking at the plot window. All right, and the last little bit here is that I wanted to do just a couple of demonstrations for some things you can do if you are going to prepare a plot for, as I said, publication or presentation. And so to do this, I had actually played with a term where I ratioed the grain to straw for our oats data. So if we take our oats data and then mutate it by creating this ratio, and that's the first step. And then the next thing we're going to do is we're going to create a plot with ggplot by comparing the yield to that ratio and coloring it according to the genotype. And see what that looks like. Okay, we didn't give it a geome yet, so let's go ahead and do that. All right, well, we've got the axes and so on. Yes, indeed. Okay, again, just so what was done here was just increase the point size, did a smooth, added color, and so on. But we're going to add some details to it. So we're adding a linear model for the geome smooth, and we're going to add a legend and put it at the bottom. So that's, cleans it up a little bit. And then we're going to add one of the things that theme does is allow you to adjust your legends and such. Okay, so this one adds the legend at the bottom. So that's the kind of manipulations that you'll want to do if you are looking at creating things like that for publication. But the last thing I wanted to mention was you're also able to, if you are trying to adjust your plots for a PowerPoint presentation that's going to be presented on a screen, you may want to add a different, okay, make it P5 because I didn't do that step. You may want to change your colors to make it so that it's brighter and bolder and easier to see, and that's easy enough to do. And then the last thing is that there is, if you go into a package called our Color Brewer, there is a palette that's available where you can make it so that it's easier for people who have red-green color blindness to work with, to see. Okay, so this doesn't help me any because it's all in blues, and the lighter blues are a little harder for me to see. But if you are red-green colorblind, it does make it easier for you to see. And then the last thing is just if you are wondering how you save your plots, there's two ways of doing it. This one is the shortcut, And you can just go up here and it'll save it as either a PNG or a PDF. You can pick whatever whatever file type you want to save. And then you can choose what directory to save it in. And we're going to save it here. Okay, and then if we go in and look, we should have our figure saved there. It's also possible to save using a function called ggsave and save many at one time. But for today, we're just going to stop with that.
Thanks, Kay. If there are any questions, we're happy to entertain those. The goal here, Clay and I talked about it, and we thought, okay, we'll try to present some of the different options, and some of the basic ones. You can generate some very nice looking plots with ggplot with only a few lines of code. A lot of the defaults for that are actually look quite sophisticated, and yet you also have lots of control for being able to manipulate those and to have different color palettes and things like that help to highlight different elements that you're interested in highlighting. And so we wanted to sort of go across the range of different kinds of visualizations that you can do. There's more than even what we've demonstrated here. So anyway, as you look into it, if you have a particular question about a certain type of visualization that you're interested in, I'd be happy to help you with that going forward.